Ladies and gentlemen, hello and welcome back once again to the briefing room. Yes, indeed, my name is Eric Cavanaugh. I will be your excitable, if humble, host for today's show entitled, and I love this title, Down to Business, Taking Action Quickly with Linked Data Services. So we're going to talk all about integration today, but really about agility and how can you quickly pull together sets of data that can help you address very specific business problems. So there is a thought about yours truly and enough about me. Our mission, as many of you now know, in the briefing room is to reveal the essential characteristics of enterprise software, and I can say honestly that you, in our audience, play a significant role. We always get very good detailed questions from our audiences in these live events, and as I think many of you now know, the analyst and vendor do not coordinate before the show. And the reason we do it that way is we want to preserve the kind of natural conversation that will evolve when an analyst takes a briefing from a vendor in a particular space. So with that, I'll say don't be shy. Send your questions in at any time. We'll have a good long Q&A at the end of this event. So we cover different topics every month. Database is next month, cloud, and high-performance analytics. This month is integration. So we're taking various approaches to the integration puzzle. And, of course, today we're talking about data virtualization and linked data services. So it's obvious, and everybody knows, the amount of data is increasing significantly in all kinds of different ways. And let's face it, the data warehouse, as it has been constructed over the years, is simply not equipped to handle the kind of fast-changing needs that business users have for building applications, either for analytics or for just streamlining operations or infusing a couple new data sets into an operation to help with either customer service or some other efficiency gain in the organization. Well, that means we have to go other ways, and data virtualization is something we've talked about quite a few times on this show over the years. It is maturing. It is growing. It's getting to be more prevalent. More and more people are talking about it, and more people are looking into it and trying to understand how it works. It does not typically supplant data warehousing. It probably almost never does, but it certainly does augment data warehousing. And also, you don't need a data warehouse to use data virtualization. It's a way of provisioning data to key business users, ideally in an agile fashion. So the other thing to consider here, you can see at that bottom bullet point, the BYOD movement, bring your own device. Well, that complicates things further. And just the heterogeneity of systems out there, folks, the heterogeneity of systems and also of data types, it's a mess. It is really a situation on our hands here in organizations that find a way to wrap their heads around and get their arms into these different systems to be able to deliver data quickly. They're the ones who are going to succeed. I don't think there's any doubt about that. So we're very pleased to have Mr. Krishnan from Sixth Sense with us today. He's been in the briefing room several times before. He always does a great job asking good, hard-hitting questions in a very polite fashion. That's what we want. We want to get to the truth. We want to dig deep into what's going on. So Denodo Technologies, of course, data integration and virtualization software company. The Enterprise Data Services platform delivers virtualized data services, allowing users to achieve independence from physical data sources. You can imagine how important that is, especially in a fast-moving industry. So with that, let me introduce Suresh Chandrasekaran. He is a recognized expert in data virtualization. He's got 15 years of experience in leading integration middleware and web companies. He's a frequent speaker. You can see him at various conferences. And with that, I'm going to go ahead and push your first slide, Suresh, and I'm going to hand the keys of the WebEx to you. And attendees, don't forget, send those questions in at any time. We'll queue them up for the end of the show. And with that, Suresh, the floor is yours.
Thank you, Eric. I'm now sharing my screen, so please confirm that you can see that. I'm looking forward to this opportunity to both present a new perspective on data virtualization, which is about linked data services, the idea of providing business entity views in a way that business users can self-service and access and dynamically search and browse and move across, even though the information is coming from disparate data assets across the enterprise and even externally, and this unified semantic layer in between being the data virtualization. So typically, if you go into any organization, what the business really wants, they want timely access to data. They don't want it just in one way, delivered, for example, in canned reports. They want to be able to discover the data, query it, browse it, search for it, understand the relationships between data. And what is timely and what information they want, of course, varies by business context. And so they want to be able to access any business relevant data, and the trust factor is now becoming a very important aspect of this. And trust again has this sense of variability. What I need to do a marketing campaign is very different from what I need to report to the SEC, and so they need to understand where is the data coming from and how much can I trust it. And that of course depends on whether it's coming from internal or external sources, and therefore being able to pass not just the meaning and the semantics and the metadata, but also the governance and the trust aspects of this information becomes important. And now I may want to access this information not just in a reporting sense, the increasing convergence of analytics with operational decision making, with actionable operational things being pushed down to the line, if you will, the frontline worker through mobile and web apps. So this means increasing number and variety of apps. And even within, let's say, business intelligence tools, you may have multiple tools that you want to access this. And all this needs to be delivered with rapid time to market, meaning I can't wait the 6 months, 8 months, whatever it takes to build the warehouse and pull it all together. And guess what? Even if I told you this is what I want 3 months ago, I may want to have the flexibility to change or update or change additional sources, et cetera, et cetera. This is the reality today. We all know this, yet we are stuck with a situation which is very difficult. We'll get to that in a minute. So one way of looking at this is business is going to look for semantic relationships, broadening the scope of the data to increase their understanding, which goes from data to information to knowledge to wisdom. They want to be able to view all this as canonical views, as customers, orders, support incidents, products, etc., and the relationships between those views as pre-integrated information, and be able to discover and self-service and access this fast, both in terms of time to market and in terms of real time. We talked about trustworthy, and then be able to build on top of that across multiple different platforms. The challenge, though, is that the traditional method of data integration is too slow, it's too limited, it's too costly. And guess what? You know, the tide seems to have turned. The data virtualization and semantic and unified ways of accessing information is gaining much more traction, and you see that even the Data Warehousing Institute, for example, which was, of course, very much the driver of the whole data warehousing phase and the long-term, traditional data integration phase, is saying that it, on average, takes 8 weeks to add a new data source to data warehouse, 7 weeks to build a complex dashboard or report. That just doesn't cut it anymore, typically. And there's still some need for that, and no question denying that. But also, people recognize they need other ways to do this. Forrester says that IT spends 1% of revenue. Now, this is not just profits or IT budget. This is 1% of revenue of a company on storing data. But 75% of that data stored is inactive or rarely accessed. So what's the whole point in continuing this replicative practice when you have the technology and the capability to access information dynamically and in real time? And that, even if you stored all this data, 90% of the data requests that are coming in are for new information. So this underscores the idea that not only is it taking a lot of time, but it's also very wasteful in many cases. And then to top off, Gartner includes this idea of semantic and data virtualization and logical data warehouse in the top technology trends for 2013, stating that central to success is enabling this technology infrastructure that helps the producers and the consumers to organize, share, and exchange any type of data or content anytime and anywhere. So that also expands the idea of data to content and unstructured world. So how exactly?
Are you going through slides right now? Because we're just seeing the first slide still.
Yes, I am going through slides, but I think then I'm not being made the presenter. Perhaps you are still.
You are the presenter. You're not. You know what it is? You're not sharing your desktop. So
Okay.
If you want, you can go to...
I will do that. I have to go into Quick Start and
say
share my desktop. Okay.
There you go.
Sorry so much. Yes, I...
Figured I'd jump in sooner than later.
All right. All right, if that's the case, apologize for that, but let me just sort of go back and quickly build on the words that I don't want to repeat this, but I'll just say that, just pause on this for a couple of seconds. And we talked about what the business wants. We talked about the canonical views of information and going from information to wisdom. We talked about some of the statistics in the market that underscore that traditional methods are too slow, too limited, and too costly, and why this idea of a logical semantic layer starts to make a lot of sense. Now, moving forward, data virtualization provides a part of the solution for meeting this challenge, and I'll come back later to why I say a part of, because I want to be realistic that this is not a be-all, end-all silver bullet, but it plays a very important role in being able to bridge this divide between what the business need is and what the real world is, which is a increasingly complex, high-volume, exponentially growing complexity of different types of sources, different types of data, and the speed at which it's arriving at you. So in order to meet that challenge, some of the key capabilities and deliverability of what data virtualization provides is, first, it has to be able to access heterogeneous data sources with different formats, structures, relational, hierarchical, multidimensional, semantic, unstructured indexes, et cetera, and bring that into a logical abstracted view, which in the case of Denodo we call an extended relational view, and then provide canonical views that combine that data from these different sources. And in that process, you have to virtually transform and clean the information. And those canonical entities need to be associated, what we call the linked data concept. And basically, then they become related entities. Now, from an execution perspective, this is all, there's more to the metadata, and the governance will come back to this. But from an execution perspective, high performance means understanding real-time optimization, understanding caching, in-memory technologies, and also, as needed, invoking the batch-oriented ways of pulling data. So the idea is to minimize replication, not just completely eliminate it. That would be too much of a purist view. But the good data virtualization platforms are very good at providing hybridized solutions that maximize performance while minimizing replication and cost. And the idea is also to create this abstraction layer, which then allows you to create information as a service, a semantic layer, a common data layer that provides self-service data services in multiple different ways that you can expose it. And very, very important, provide integrated governance, lineage, understanding where the data is coming from, how to secure it either at the source level or at the virtual level, and then perform the transformations in data quality. So with that in mind, I'm going to sort of set up a scenario here to do a very quick live demo. And the way I'm going to do that is by clicking to a video, and then I'm going to talk to this. So first, let me assume that I'm the IT guy. I've been asked by a senior member of the business staff reporting up to the executive C-suite to provide in a telco company view of customers who are at risk, which of course requires me to get information about high-value customers and those that are at risk. So I provide this report to that business person, which sort of lists the thing, but that person wants more. They want to be able to browse through the data themselves, so they use Excel, which is a simple tool, to introspect Denodo, the virtual layer, select the objects that they want, pull that all together, and build their own pivot tables or reports, etc. Okay, that person is now pretty happy, but they want even more. They say, this is okay for me, but what about the line workers who want to be able to build this on their own and browse through all of the entities? I say, well, there's a way to expose this as a RESTful linked data service. They can be exposed to all the entities that they have access to. So they can click on those entities, they can search for them, they can browse through them and actually find related entities like open incidents, and when they check on the related entities, they can further drill down and look at possible diagnostics, which leads them to a knowledge base, and they can come back, they can search, and guess what? This is not just available in HTML. You can also expose this as JSON or XML, and we're calling this the fully RESTful linked data services, so that this can also be exposed through mobile apps, et cetera, et cetera. How did this happen? Well, the backend actually shows you that this customers at risk entity is really a combination of multiple different data sources and data types that are being organized into these different entities and then being related. So you see the customer entity, you see the invoice entity, you see the incident entity, and you see the knowledge bases, and so on and so forth. So if I have to really come to any one of these, I can see that those entities are here, my canonical models. And then I have associations between those canonical models. So how did I get there? So let's take a look at how you would build one of this. So I'm going to go to the customer entity. And when I'm looking at the customer entity and I execute it, of course, I can use my standard SQL here, select star, and provide some input parameters, and I get my data. But when I really look at underlying how did I get this customer entity built, well, it comes from multiple different databases and data types. So first I'll go and show you how the person developing this had to connect to a database, for example. And this is a JDBC source, and you can see you can connect to various different styles of databases by providing the adapters. And when you introspect that source, you're able to go into any one of those tables that are available and click select base views, and then that creates the logical view of this information in the virtual or semantic layer. So on, you have created multiple different base views. Now let's go down a little further. We'll come back to the different types of sources later. Now we're looking at a web service. Now you'll notice this is a hierarchical data source, but by specifying a WSDL from an Amazon invoicing system, we're able to bring that information back as a hierarchical structure, but I can still execute SQL against this. This is the power of the normalization of the extended relational model, which is unique to Denodo. Now I'm going to MongoDB. This is a document or style database, a NoSQL database with JSON files and documents and logs. Again, we're able to parse through that, bring that back as though a base view, which looks very much. And the final example here is a knowledge base. This, in fact, you will see is coming from a forum. And it has indexes, etc. I'm able to now relate knowledge bases to incidents, etc. So the customer information itself and some of these information is a conglomeration of these sources. Once you have them in these relational kind of views, it's very easy to combine them and join them. Now you can publish them not just as SQL outputs, but also as REST web services and SOAP web services. And the REST outputs you already saw. But in addition to that, you can also publish them for SOA as widgets like portlets or Ajax widgets or SharePoint web parts, etc. And so that sort of brings you to from the sourcing to the publishing. Now coming to governance, we want to understand where is this information coming from. So you're looking at a lineage chart that tells you exactly where, and you can pass through trust parameters like timeliness and the source refresh capabilities and things like that. And finally, coming to the idea of performance, you're going to see that all different branches of the tree can be they're all optimized for real time, but they can be cached full or partial. The caching can be on disk, it can be on in-memory, it can be triggered by events, it can be triggered by time, it can be triggered by query patterns. So lots of sophisticated options on how you can do the caching. And beyond that, you can even take what the system automatically optimizes, such as join methods, the push-down strategies, etc., and provide hints for the system to perform even better if you don't like what the system is doing, which of course it exposes to you very fully. So that was a very quick view of what can be done. And as a final point, I want to emphasize that even though you've seen a very small part of this, you can see how we have built associations. I want to just quickly touch on the idea that Denodo provides the capability to access the broadest range of sources. So starting with unstructured information, indexes, with semi-structured information, which actually in this case I'm going to show you a very quick example of how you can access the web. So this is a telco. They want to understand from Amazon what devices are available for this particular provider. Of course, we would do this as a human being interacting. But here you see a wrapper for that website that can actually execute the same query in an automated way, learn from what you have provided as examples, and retrieve that data automatically in a relational format. So that's the semi-structured that can be used against websites, against PDF documents, etc. We already went through the NoSQL. We have multiple ways to connect to Hadoop using HBase, Hive, HDFS, Impala, S3, different SaaS applications, also social media, of course the major Oracle, SAP types of applications, major OLAP databases, and several other data warehouses and databases, etc. So with that, I want to go back and wrap up my presentation by emphasizing what you just saw here. So what you just saw here is, let me go back to this. Okay, so going back to the slideshow mode is basically a technology that is very broad in that it sits between the disparate data sources, and as we've seen very clearly here, a library of wrappers that can connect to highly structured to highly unstructured data sources, including human automation of processes for unstructured and semi-structured data in a read and write fashion, normalize that data, provide the tools to transform, integrate, and improve quality, both built-in functions and extendable functions that can invoke third-party data quality and other tools, and then publish them as linked data services in multiple formats, as SQL, as web services, SOAP REST, as widgets, so on and so forth. In the execution time, there's a combination of real-time optimization with multiple modes of caching, and there's a built-in scheduler or ETL tool in the Denodo platform that allows you to choose what branches of the tree need to be prefetched, what branches or nodes in the tree need to be cached, and what the rest can be allowed for the optimizer to execute in real time. And coming over to the right side, there's a set of capabilities for governance, like lineage, change impact, introspecting this virtual layer to understand all of the data objects and their relationships, all of the metadata associated with that and how that can be imported and exported for top-down modeling, bottom-up modeling, contract-first modeling, and leveraging existing industry models and things like that, and extensive security options for providing access control both at the source level, at the intermediate level, and then for users to access this information. So that is what was done in order to connect these sources, build the associations, and expose that to the top. So what you're seeing is a capability, a set of capabilities for logical abstraction and decoupling, for on-demand real-time access. But again, it doesn't have to be that. It can be a hybrid mode, as I've already gone over. Very importantly, the semantic integration of varied data types, multi-structured data, whether they're structured, web, unstructured. For some people, unstructured stops at XML, but in Denodo's definition, it goes all the way to Word documents, emails, pictures, etc., and all the way on the structured side from legacy to databases, etc. Agile data services provisioning, very important. Now that you've integrated all this information, multiple ways to expose the data and RESTful approaches such as the ones you saw, JSON, linked data services, is becoming extremely popular with the preponderance of mobile and other applications. And governance and trust are still very, very important, including security. So why do this? For business speed, flexibility, and cost, we've already established the need for this upfront, so I'm not going to repeat that. But you know what? This is not just being driven by business. IT people, increasingly, CIOs, chief architects, others, enterprise architects, are recognizing that they need this single unified data layer. They want to be proactive in providing the business flexible capabilities to access data as a service, as linked data services. And think about it. Financially, you've already invested a lot in your data assets, in your data integration, in your databases, and you're probably spending a lot of money acquiring new data. How do you expose that and increase the shareability of data so that it provides the maximum financial impact or return on data assets? So this point I mentioned about data virtualization being part of the solution, this is very important, and this is an important differentiator of Denodo in that many companies have very much focused data virtualization on the BI stack to replace in some ways or complement the data warehouse and ETL strategies and MDM strategies, which is very true. But Denodo takes a broader view. We recognize, for example, that corporations have the replication stack, but they also have the SOA and BPM and ESB, what I call the propagate stack. But come over to the right, you have your unstructured stack, search, indexing, content and management systems, and collaboration. Don't forget the people, the portals, file sharing, email, social platforms. So at one level, Denodo adds to your capabilities by providing this real-time capability for federated query across multi-structured data sources. But what it also does, and more importantly, provides that abstraction, provides that unified semantic layer between sources and your middle tier and between the middle tier and your different applications so that you can migrate these, you can change these, you have consistent information coming from your applications and users onto the sources, and you're able to govern this at a unified semantic layer and deliver linked data services. So this is not just an architectural talk. When you look at Denodo's customers and their breadth, and they're all leaders in their industry, you'll see this variety. You'll see agile BI and self-service and dashboards. You'll see ways to collect information in the case of Homeland Security, do the analytics, and then push that into the operations room and make it actionable. You'll see high performance even in the largest corporations. And you'll see companies using our technology to integrate Facebook and Twitter and unstructured data and presenting sort of unified views. Now, this is all may sound like intelligence, but it goes beyond that. Very large companies are using us as an integration layer and aggregation layer for feeding very powerful enterprise applications like smart services, or managing migrations, and in this case, a company reorganizing into two separate companies using these DV layers as an abstraction layer, methodically building out multiple data services that are exposed to application developers for significantly reducing the time that it takes to develop new applications and growing that into an enterprise SOA kind of capability. This kind of depth and diversity of use cases is only possible when you have that broad vision of what is data virtualization. So with that, I'll sort of close my argument that the view of data virtualization is not only taking root in organizations, but is also very important for you to consider the depth that you need to look at the best of breed solutions that provide the broadest support for data sources, the most provisioning options for multiple applications, and high performance defined not in a unilateral way, but in combining real-time caching and ETL types of tools within the data virtualization platform, and very importantly, look for governance and security and new ways to deliver the data like linked data services. So with that, I'll return it back to the hosts of the conference, and we'll be happy to take questions.
Okay, good. And let's go ahead and hand the keys over to Mr. Krishnan. Krish, I'm going to go ahead and give you the keys to the WebEx.
Sure.
If you want to just click on that, there you go, you got it. You may have to scroll down through a few slides to get to yours.
Yep.
And there you go. With that, we'll hand it over to Krishnan. The floor is yours.
Thank you. Thanks, Eric. Thanks, Suresh. So picking up on where Suresh has just ended his discussion, I want to bring in a few additional viewpoints, to set the stage. And then, we will jump into a lot of interactive discussion with questions and pointed specifics in terms of, where do we see the next generation of this solution evolving to, right? I mean, we understood what are the things that can be done, with the platform and the capabilities, but we also want to understand the actual depth of the scale itself. And to do that, we first need to define, a tipping point that we'll stand upon today, at least at this minute of thinking. And the tipping point that we are looking at, heading our way is the viral change that is now assuming a critical mass. And what I mean by that is, in the previous few minutes of Suresh's explanation of how companies have evolved into applying data virtualization as an integration platform, as an integration engine, we have seen where, data virtualization either is a connector or a conductor or a transformer or sometimes even a recipient of, a change of data. And then it actually exposes that change to an end consumer through an integration touch point. When you reach that kind of a tipping point, typically in an organization at at any scale, you are actually now having enablers and empowerment that actually will help you to reach the next point, which is the actual mass commoditization of that result set into 100% variable result scenario. To give you an example, let us actually look at what we are studying today. If you look at what we are studying today, we have gone from studying transactional behaviors to understanding behavioral behaviors. And what we mean by that statement is that today we are not looking at why somebody goes and buys a pair of jeans at a store or at a point of sale or at an event. You are rather looking at what propelled you to buy that particular pair of jeans that you just bought, whether it was pink in color, whether it was purple, whether it was faded, whether it had bullet holes, whether it was crimped, whether it looked used as it came off the shelf. So when you're looking at these kinds of what made you buy that particular pair of jeans in your hands rather than what made you buy a pair of jeans, there is a huge depth in the question that you're asking. And the studies that go with that question are way beyond what you normally would sit down and interpret from a POS transaction. So when you look at this change of mass commoditization behavior to say that I am now wanting to understand why you went and bought this particular pair of jeans rather than why did you buy this pair of jeans. There is a difference in this particular pair of jeans versus this pair of jeans, and that in general is what we're talking about. Now, if you take this step to the next extent, which is actually to now look at it from a medical perspective, you want to look at why a particular doctor went and prescribed a particular therapy, which is more gene culture related to liver cancer as opposed to going the normal route. Now, what did prompt this doctor to take that step? What were the decision-making points? What were the convergence points that in the patient's case actually pointed to this particular mode of therapy being more responsive? What actually changed the behavior in the patient in terms of response that gave the doctor the confirmation that they could actually take this particular point in case therapy, which is more gene related, and apply it. So when you're looking at these kinds of the needs, the relationships, the results, then we have to go back and ask the questions why. And that is when you understand that the growing trend that is changing the expectations for BI rather than it being told by anybody that this is what BI is now changing to is the fact that we are expecting everything to be available to us at the speed of Google. We're expecting data to be there. We're expecting information to be available. We're expecting the information to be available on demand at any point in time. So when you're looking at these subtleties that start dropping in and subtleties that start falling into place along your lines of thinking, along your lines of interest, you now start looking at what is it that you are going to lead. And that is where, if you take a step back and take a look at where we are going from the business evolutions of product to customer focused shifts. And what we mean by this is the fact that gone are the days where we were looking at product driving a customer's behavior. Today, it is the customer that actually owns, shapes, drives, and eventually accomplishes the outcomes for a company in particular, any company in particular. Because if you are looking at any company, in the end of the day, they are making either a product or a service. And it's either the product or the service that is going to be sold to this customer. And that customer is the customer who is bringing in the confidence factor, the loyalty, the trust And when those three pieces converge together for any customer, automatically you're going to expect a lot of results coming in through. So now let us take a look at what does it mean from a BI perspective then, right? I mean, we understood that the need for BI is changing. We understood that the customer production shift towards customers owning and driving loyalty, and towards customers shaping up the business has become very clear. Now let us look at what does it mean from the forces that shape the business themselves. Then we're talking about new data, we're talking about new technology, we're talking about new consumers, and we're talking about competition now being a part of the force than ever before. As you look at it then, at this point, here's where we land with the state of the data. And this is where I think I would want to ask my first question to Suresh, is the fact that with all the information that you're presenting, Suresh, typically in a customer situation, what are the top three, if you would, are the top three pieces of information that you would say any company is very interested in from a state of data today? I mean, understanding that this is all the data that a customer can get in an organization, right? I'm going to assume for a minute in our discussion that we are having tons and tons of data that a customer is getting. What is it that the customer is going to be interested in?
If you're talking about an organization, as I understand this, Krish, that's a great question. I think you're posing something very challenging here, but let me try to answer that. We used to think that we want a lot of depth of few pieces of information, but I think business owners are increasingly saying they want the breadth of information that alters their perspective and makes it very actionable. So we're going from a very static view of the world of data to a very dynamic view of the world. Of course, in terms of type of data, of course, always customer information is very important. The market, if you will, this behavioral types of information that you talked about is very informative, because it's not the transactions that as you said, we did in the past, but what are the transactions we're going to do in the future, and that's much more influenced by sometimes not even organizational data that we may own, but behavioral information that may be coming from many sources. But of course, you have to understand your own customers, and then your own offerings, whether they are products or services or, et cetera, and then connect the three. So if I understand, I would say, in my view, the top three would be if you understand your customers, you understand the factors that are going to make them a buyer, not from the past perspective in the future, and then all of the things that you have to offer, and you can make intelligent choices in connecting the product, service, delivery to the customer based on those factors, behavioral or dynamic factors. I think you have a growing business. At the end of the day, that's all business is all about, increasing revenue and increasing profit, and I think that's sort of from a commercial business perspective. So I would say those are the three top ones, but how you get that is very different mindset. We're getting from a static mindset to a dynamic mindset, from a transactional to a behavioral mindset.
Agreed, Suresh. I mean, while I holistically think that you did hit the first three, now let me ask you another question, which is related to this, right? When you talk about getting all the pieces of information together and then putting it in front of the user, right? Obviously, there is a back-end process that needs to be, constructed along the way for all this data integration to happen. What would you suggest would be the top three key integration points in the back-end that we would need to look at?
Are you talking about the sources of information, or are you talking about the sort of the general topics that integration should address?
Well, the general topics that integration should address. Let's keep it generic enough. Absolutely.
Sure. I think my top three here, again, let me sort of preface that with a little anecdote or a statement outside here. I tell my children who are still in school right now that the future belongs to not necessarily those who have the most knowledge, but those who are adaptive enough to gain new knowledge rapidly, depending on the problem that they face at the time. I think the data world is the same way. It's not about how much access or how much data I have stored or I can, I have it in this big data warehouse collected and normalized in one place, but how quickly can I bring the information I need for the problem at hand. So from that perspective, I'd say, going back to your question, the three top things are, I really need to understand metadata very, very, very well. And metadata is not exactly the same in the terms of its format, in terms of how it's expressed for different types of data sources. But the integration first challenge is not necessarily to integrate the data itself. In fact, that used to be the big focus in the past. Going forward, the big focus needs to be, I need to understand the metadata of all of the different types of data and information sources I have accessible, and bring them together and make it accessible enough, discoverable and browsable, that on demand I can bring them together and deliver the information you want. The second most important thing is I need to understand, and the challenge for integration is I need to understand the trust, if you will, or the, and trust is a broad word I'm using, and that includes in that the lineage, the meaning, the semantics, the timeliness, where is this information coming from, and how much can I rely on this information for the particular problem at hand. And it's not a uniform standard, so it needs to be a variable standard depending on the problem, but I need to know what I'm getting into if I'm bringing all this disparate data together and be able to do it dynamically. So there needs to be a lot of that built in. And I would say the third big challenge for integration is, of course, performance. Again, here, it's a combination. What is my problem at hand, and how much of this information needs to be truly real-time, how much of this information can be managed in some kind of near real-time, et cetera. But these types of capabilities then point to the data integration platform to be not sort of monolithic in doing one thing extremely well, but being the very best performing kind of integration platform that can deal with metadata, can deal with the trust and lineage issues and the performance issues in a very dynamic way depending on multiple different scenarios. And I think that's really what data virtualization and we at Denodo are striving to do.
Awesome. Thank you. Thank you. So now moving on, I'll introduce my next example, right? This is a tweet. It's a very popular data integration challenge. Suresh, I'm sure you've seen it, and many of you, in the audience have seen a tweet like this coming out like every day. I mean, every hour, sometimes multiple times in an hour. And the tweet just reads, "At JDO, very disappointed with at United, at check-in, lousy service, bad management, long lines, found fail." Now, when you look at this as a tweet, there is no relevance, if you will, that it directly attaches to your business, especially if you are United as the airline company and somebody is writing about this about you, and you're like, okay, fine, I'm going to have a bad customer every hour. Somebody wrote bad about me, fine. I'm having 10 bad customers an hour. Somebody is writing 10 bad things about me. If you're now looking at it from a holistic, what was the damage that every single tweet took at that point, then you'll be really wondering, in the 4 hours, it had 20,000 retweets. This one tweet was retweeted almost 19,999 times. That is a significant challenge for a company to look at, especially considering that, it is your brand and it is about you as a company that somebody has written. Now, if you normally look at it from an IT perspective, there is no challenge here, because you're saying, I have a 140-character text, I'll store it as a string, and I can bring it up and give it to a user if somebody wants to look at what was tweeted. But that's not the goal here. The goal is to understand what is the business issue here. And the business issue says that it is a negative sentiment about a brand, and it is during a check-in process, and the time is a long waiting in line, and the impact is that it's being shared 20,000 times. So when you look at it from that perspective of where does it hit the actual brand itself, it won't hit the brand today, but it'll hit the brand tomorrow, it'll hit the brand the day after tomorrow, it'll hit the brand the week after. It will hit it each and every time there is a check-in process and there was a long line. Somebody will bring up this tweet and they will repost it and they will say, I had the same issue today. I had the same issue today. And that is where we want companies to start thinking about bringing this external data. That is where we're talking about bringing this external data. So what are the challenges with big data then? I mean, we asked Suresh a few, and We have discussed a few. Now let's actually round it up and let's look at what are the challenges. The challenges are that it is complex, it is ambiguous, it is structureless, it is minimally organized, there is a lot of data quality issues, there is a lot of metadata issues, it needs intervention, it needs context, and it needs analysis. Now, without doing any of this, just bringing in any data set, whether it is tweet or Facebook or whether it is Instagram post, it doesn't matter where it comes from, or it is from a structured system, or it is from an email engine, it doesn't matter. We're still going to have these challenges associated with data for good in the system, always present. So what do we do then? How do we actually take care of these challenges? Now, one of the views that Suresh shared with us, and he gave us a few different perspectives, and here is an additional one, is that instead of letting IT run the data and stream the data and chain the data together, let's put business in the middle of all of this. Let us look at making business to become the holder of the key to the castle and look at what they can bring about. And how does this analysis change? This analysis changes a little different than how you would analyze data if you were to analyze it through a normal IT, scheduled process. In that from acquisition to search to pre-processing the data to creating the metrics and to visualizing the data, business actually will own and run the entire set of activities. And that is a huge differentiator. This is something that is huge. This is something that we have never done before in our industry. We have attempted this a couple of times in the recent past, and we have got a lot of success at it. And at this point is when you need to understand that IT still has a role. IT is not going to walk away saying that, okay, I don't have anything in this world anymore. I'm not needed to do any big data work. IT definitely has its role. IT has its role as the provider of that entire infrastructure. IT has its role as the manager of the framework. IT has its role as the custodian of the domain, and all that good pieces and parts are still going to be there, and IT still has a role in it. And then comes the whole processing cycle itself, and this is where we need to understand that the term data scientist is not a unicorn. It's not a one-person show, and I'm pretty sure Suresh and Eric, both of you would agree with me when I make this statement that the data scientist is a team of at least 2 people organization, if not 3, because you will need somebody who understands the data side, but then you also need somebody who understands the process side, and then you'll need that third person that's going to be that why, that external why driver that actually drives that engine multiple times, asking those sets of questions. So if you're looking at these analysts, these data scientists, and these task managers and their tasks and how they are building this engine together, we realize that we are actually talking about changing the pace of the game with a technology like data virtualization, right? I mean, when you look at big data and when you look at the challenges in big data, and then you look at how to integrate big data and what are the changes that you will need to bring about in your system, you could either go about the Hadoop route, or you could go about a data virtualization route. You could go about a content management platform route. You could also go about an adapter-driven route, where you're just bringing in an adapter, and an adapter is going to give you 5 metrics and 3 dimensions as an output. So the question is it's not about what you're trying to solve. It's about how we're going to solve it and what is the end result going to be. And that is where I think we need to now come back to the question of asking, what else is data virtualization going to help us do apart from the integration touch points that Suresh spoke about? And with that, I will turn this over to Eric with that question as the open-ended last question to Suresh. I will turn this over to Eric to lead us through the rest of the questions.
Okay, good. And we do have a bunch of really good questions in here, so thank you so much for turning us over to the Q&A. So let me just kind of dive right in here. We got a whole bunch of them. I'll start you with this one. So it's a very specific question. One of the attendees asks, in using OData, public class, my service, data service, Denodo object, are you using entity framework, or is it a customer Denodo object? Is this the service to use in reporting with Power Pivot? Do you understand what he's asking?
Sure. I think at a high level, the Power Pivot was just an example, but the concept is very similar to OData without using the specifics of that technology. Everything that's exposed from within Denodo is a virtual data object. Now that virtual data object initially resides in what we call this extended relational model, but in the published layer can be exposed as JDBC, ODBC, ADONet, or as SOAP Web Services, or as REST Web Services, or as XML, or as many different things. But these objects can interact with each other in the sense, or they can be associated in the same sense of primary foreign key tables. And that's what we call linked data. And then when fully exposed as RESTful web services, we call them linked data services. So the concept is similar, and the usage points, therefore, are not just Power Pivot or Excel, but it can be any BI tool, business objects, MicroStrategy, Tableau, ClickView, etc. It can be any other middleware tools, like if it's exposed as a web service, it could be JMS and ESBs, etc., or other applications. It could be mobile applications. It could be portals. It could be so on and so forth. So it's really a logical layer where you create and assemble virtual data objects, which are really a conglomeration of multiple underlying disparate data sources.
Okay, good. And there's another really good question here. One of the attendees asks, so in order to process the data in real time, do you have to have designed the model from the canonical views before? Are those canonical views basically similar to tables?
That's an excellent question, and that is largely correct. Now, the canonical views, and here's the interesting thing, they're similar to tables, except that because of this idea that we're dealing with heterogeneous data, this middle layer needs to be able to hold different data structures. So it can be flat structures, it can be hierarchical structures, it can be semantic structures like, RDF, but that's the value of the Denodo platform, is that it understands the idiosyncrasies of the sources and builds up these normalized views from which you build the canonical views. But I also need to add, it's not just a bottom-up approach. We also provide the capability to bring in a top-down model. Maybe you are in the oil and gas industry and you want a PPDM model, or you want an Accord model from industry insurance, or so on and so forth, HL7 and healthcare. And what you can do is bring down a top-down model or a contract-first model from a logical modeling tool, if you will, and then connect up the bottom-up approach. But yes, there is a process involved of defining these canonical views and then reusing them as you build new views. And then the execution, of course, the questioner asks, is it in real time? And as I mentioned very quickly, of course, it is real time, but certain nodes in the tree can be cached, and certain other nodes in the tree can be prefetched using our scheduler product. So in the end, a typical solution, let's say, could end up being 70% real-time, 20% cached, and 10% batch prefetched or pushed out. But it's that flexibility that allows you to make the most use of data virtualization.
Okay, good. And there's a follow-up question here. So where is the linked data services? Where are they created? Within a data warehouse, or are they just attached to the data warehouse? Is it analogous to the Power Pivot linked tables?
Yeah, so the idea of a data warehouse, since the person asking the question is, so you have to think of the Denodo, the data virtualization layer, as a logical data warehouse, is the term Gartner uses, or as a virtual semantic layer if you want to think more web services, or so on and so forth. So this idea of linked data services are, yes, created in this logical layer, and they are linked because they link canonical views of business information, and they are services because they can be exposed as, let's say, fully RESTful data services. And of course, I'm not going to explain what fully RESTful means, but it has the same characteristics of a web, for example, where you can browse, you can search, you can traverse relationships between resources like on the web, and that's what a RESTful linked data service is. But that's just one of the options to expose it. If you choose to expose this purely as a virtual database table, that can also be done. But this is done out of the virtual layer, not necessarily a data warehouse, but this virtual layer that you can think of as the logical equivalent of data warehouse.
Okay, good. And you mentioned semantics. Can you talk about semantic capabilities in the tool? One of the attendees is asking if you address sentiment analysis and comments back in the 60s, bad meant good, that kind of thing. Can you employ those kinds of transformational rules?
To some extent, yes, and to a fuller extent, yes, with the help of some of those third-party tools. So what the first step in being able to relate multiple data sets is being able to normalize them to this common. In fact, one of Krishnan's pictures was this kid staring at Lego building blocks, I thought. And that's important. You want to bring these different sources into combinable format. But if you want to perform, so in our case, yes, we do take indexes of unstructured information and allow you to match it, as in this particular example I ran through quickly, a knowledge base against incidents, and the incident might have a code or something like that. But if you want to do something more sophisticated, like such as understanding the meaning or sentiment, etc., you can import a ontology or a, let's say, a lexicon as one of the sources and reference against it, or you can also have the option of passing that query to a third-party tool that's, let's say, just focused on sentiment analysis in the financial services or stock market space, and get a return score, which then appears as a table, which can be combined with other tables and then exposed as a, a combined data service. So both are possible. We have some capabilities built in, but we also have the capability to extend the platform by calling third-party services.
Okay, good. And here's another really good question for you. One of the attendees asks, and I'm very curious myself, how does the Denodo platform interact with a search engine such as Lucene or Solar? How does it know how to query a search index, that kind of thing?
Well, and as the questioner correctly points out, different indices have different parameters by which they interface. So in fact, Denodo itself internally uses Lucene as part of our search and indexing tool that Denodo comes with the Denodo platform. If you look at the spectrum of sources we connect from all the way from adapters for legacy and databases and data warehouses, we also provide our own indexing engine, our web automation engine, but we also have wrappers that connect to Google, Fast, Autonomy, and other search indexes, and they all have slightly different semantics. Similarly, content management systems like Documentum and things like that. So the what a connector or wrapper does is it basically introspects those other indices and brings them in as an inverted index. If you use Denodo's own indexer, which uses underneath Lucene, we do the indexing job itself, the crawling, and then invert the index to appear as a relational table, which again provides you this extended relational model, Lego building block to start combining on top of that.
Okay, good. And here's another good question. What are some of the things to consider regarding the security around data virtualization? Are connections to partner databases and services digitally verified? What are the different layers you can apply security to?
Yeah, and this is an excellent and very good question. So security, apart from things like encryption and things like that, which are also supported, I think broadly at a high level, you want to think of security at 3 levels. What sources can I access, and do I have the authentication to access those sources? Sometimes that's an administrative level user who is providing sort of system level access, but you can also use pass-through credentials coming from the actual user or application. The second level of security you want to think of is, now I'm not just solving one problem. A virtualization semantic layer is going to build out data services for the future, reuse them. So we end up seeing customers having multiple developers or development teams saying, I'm going to develop these base level views, and other development teams are going to come and build on top of them canonical business views, and other developers are going to do it. So in the middle layer, the security is around metadata security. Who can change, who can define, who can alter, and who can build on top of. And then the last level of security is at the user level, the end user, business application, etc. And there, of course, we integrate very well with LDAP and Active Directory and other sort of role management types of systems. But then we permission specific virtual views at a very specific row, column, etc. level, and we are sophisticated enough to also do policy-based security. So certain times of the day, certain people can access it. Other times, they will be shunted to the cache. So there's layers upon layers of security, and I don't mean to overcomplicate it. 3 layers, but it's very important to understand how to use them because you're effectively creating a logical data layer for the entire enterprise.
Okay, good. Here's another good question, very specific question. So one of the attendees asks, does this work with the BISM tabular model using DAX in the same manner as SSAS uses MDX?
So I am not going to be able to sort of, I will take that some part of that question offload, but I think part of this is the same manner as MDX port alert. So yes, we do have connectivity to different MDX sources, multidimensional sources, and we are able to translate them to a relational model if necessary, or leave them the way it is and pass through analytical queries. At the same time, if you want to combine some of these MDX types of sources with other types of sources, maybe they're hierarchical, maybe they're relational, maybe they're triplets, then we're also able to do that. So the model, of course, is represented in Denodo, and again, I emphasize it's something unique to us because we deal with so many different sources, is this idea of an extended relational model. So it's relational in appearance, but underneath it retains the idiosyncrasies of these different data types and structures.
Interesting. Okay. Another attendee asked another really good question. You talked about embracing this sort of RESTful approach with Denodo. The attendee asks, what additional advantages would your users get if they enabled RESTful access to their applications as well?
Well, that's a different layer, and I want to emphasize that RESTful access is becoming increasingly popular because if you think about it, Forrester, I think, also mentioned that 60+% of all application development that's happening today is either for mobile or cloud platforms. That means more apps are being built for these, and they love to be able to access data in an interactive fashion that's sort of like lightweight JSON, et cetera, provide. But we also have large use cases in customers for classic data warehouse extension, BI, Agile BI, which of course access data as SQL. We also integrate into SOA and applications, which of course want SOAP-type web services, and sometimes SharePoint and web parts and things like that. So of course REST is on the rise, and the question of the application on top itself being RESTful, of course, that sort of think of it as two logical layers. We are providing data services, and applications can then provide the logic services. But the data itself being RESTful has other advantages. You can actually browse through them, you can query them, you can search for associated data sets before you decide what exactly you want. So it provides that sort of capability that we all sort of go to. One of my customers called it the single point of reference, not the single source of record, but the data virtualization semantic common data layer becomes my single point of reference to discover dynamic data as it's being added to the enterprise. And then from there, I build applications on top of that. So it's an excellent concept. And in fact, it was Oppenheimer Funds who said that. So credit where it's due.
Good. All right, I'll throw one last question over you. It's really a comment, then I'll throw a question on top. One of the attendees notes that self-service reporting can often be fairly unreliable. So along those lines and with data governance in mind, what do you suggest organizations do in order to employ the kind of guardrails that are going to keep people within their boundaries as they try to build these applications or build these new analytical views?
Right. So first thing is, you expose only those data sets to those people who effectively have access to that. So obviously not everything in the virtual layer is accessible to everyone, certainly not to change the models or the data models, et cetera. So there may be consumer-only views, there may be consume and edit views, write-back views, et cetera, that can be all. But one of the aspects is that. So if I have needs to understand customer incident, et cetera, product, then hopefully you're providing not just the access to the information, but also the trust factors associated with this, which comes with the lineage. When was the data? Where is it coming from? What is the source, et cetera? And then you're trusting, to some extent, the business user to make use of that trust information to construct their reports and their understanding. At the same time, if you want to make this consistent with, let's say, your corporate reporting, you're able to do that by actually comparing where exactly did this query come from and how did it introspect through the virtualization layer. So you can have complete audit logs of all the data that's being accessed through the virtual layer. So you can actually see who is using which data services, how, and you can sort of trace back to the sources which provided that in time, so that if there were any discrepancies, so to speak, between report from Mr. A and Ms. Y, you have the ability to put back trust in those reports.
Well, good answers to all the hard questions. Big thanks to all of our audience members out there throwing the curveballs at us today. That's what keeps us all on our toes here in the briefing room. So a big thank you to Krish Krishnan of Sixth Sense, and, of course, to our friend Suresh Chandrasekaran of Denodo Technologies. We do archive all these webcasts for later viewing, so you can hop online to InsideAnalysis.com and look under the webcasts section under Briefing Room, and you can find all the archives of the last 3.5 years or so, folks. We've been doing this for quite a while now. But thank you so much once again for all of your time and attention, folks. With that, we're going to conclude, but say thank you again for your time and for your attention. We'll catch up to you next time, folks. Take care.
Thank you, Krish. Thank you, Eric.
All right,
thanks,
guys.
Thanks. Bye.